Welcome back to Math 103. This is video number 18 on growth and finance. How much is the total value of the investment at the end of the third year? We reasoned out that it needs to be the sum of the contributions of the three separate $1,000 investments, each one of which on its own grows a certain amount depending on how long it was sitting in the bank, if it was sitting there for very long at all. When we add these up, it happens to equal $3,121.60. Great, we compute that all out, and this is what we get. But we can go on to ask, why does it make conceptual sense that this value has to be greater than $3,000? A way to think of it is that even if the interest rate were zero, we would still have these $1,000 contributions, three of them, contributing to the total amount at the end. So even if the interest rate were 0%, then we would have exactly $3,000 at the end. Since the interest rate is greater than 0%, there is some interest accumulating in addition to the $1,000 that came out of our pocket, and therefore it's something greater than $3,000 in the end. I mention this because this is a good check on the plausibility of your final answer. Whatever you get here should be somewhat more than $3,000. It's very important in this scenario to understand that there are separate investments, that is, separate contributions, and each one grows a different amount in the end. A helpful way to think about this is to imagine that at the end of each year, you put your new deposit of a new $1,000 into a new bank. You probably would not do it this way in real life. You would accumulate quite a large number of bank statements every month. Okay, that would just be inconvenient, and it would make all the bank managers in your town really mad at you, but it's helpful to think of it this way. Think of each new deposit going into a new account at a new bank every year. That way you can sort out how each of your different deposits contributes to your overall total after some period of time. So after 3 years, your first $1,000 in bank number 1 has grown into a certain amount. Your second $1,000 in bank number 2, deposited a whole year later, grows into another amount, and the third $1,000 in bank number 3 grows into yet another amount. This is the one that didn't have any time to earn interest at all. Altogether, you have accounts worth this total, this sum of terms, each of which is 1,000 times 1.04 to the something. We have just worked through an example of what's called an annuity. An annuity officially is any collection of equal payments made at regular time intervals. So in that example, the equal payments were $1,000 each, the regular time intervals were once per year. There are many real-life transactions that are set up as annuities. One of these is your monthly rent. Right? At least over the course of a single year, the payments are always for the same amount, typically, and they're typically due on the first of the month. That's an example of an annuity. In this chapter, we're going to look at two important general types of examples. They are called by the slightly intimidating names fixed deferred annuities and installment loans. We're not going to be intimidated by those names. We're just going to understand conceptually what they mean. First, what is a fixed deferred annuity? Think of a savings plan. This is the way to picture it. You've got a savings plan in which you deposit the same amount of money, the same number of dollars every year, or every month, every week, whatever the time interval is. It's always the same time interval. Now, these payments earn interest along the way. So it's not just the payments themselves, but also the interest they earn that accumulate into some large amount in the future, and that's called the future value of the annuity. So the key feature here, what makes a fixed deferred annuity a fixed deferred annuity, is that regular equal payments come first, and then a large sum appears at the end. What then is an installment loan? Well, here the name is a little bit more suggestive. It's a loan that's paid off in installments. So think of a loan whereby you borrow some large amount in the present, we'll call that the present value of the annuity, and you pay it off gradually in payments of the same dollar amount every year or every month or every week, whatever the time interval is, it's always the same time interval. These are regular payments. So many loans work this way in real life. Student loans, mortgages, car loans. Along the way, so while you're still in debt, your debt is accumulating interest charges, but you do eventually pay it off. So a very important practical question is, how much do you have to pay each month so that the debt really does get paid off, and paid off by a certain date, instead of just growing forever? The key feature that makes an installment loan an installment loan, as opposed to a fixed deferred annuity, is that here, the large sum changes hands at the beginning, and then you have regular equal payments. So a fixed deferred annuity was the one where you have payment, 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 large sum at the end. Installment loans have large sum at the beginning, then payment, 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 payment. Now let's focus on fixed deferred annuities, and let's go back to our example of investing $1,000 at the end of every year, year after year, in an account which pays 4% interest compounded annually. So we're not getting involved yet with more frequent compounding. We're just thinking about annual compounding, and again, the interest is paid only at the end of each year. Before going on to the next video, answer the following two questions. How much is the investment worth in total at the end of the 6th year? And is the result of waiting until the 6th year and seeing how much you have twice as much as the value at the end of the 3rd year that we already computed?